Okay, this is problem number 5 of our related rates. It reads, if x, y, and z are the lengths of the edges of a rectangular box, the common length of the box's diagonal is s equals x squared plus y squared plus z squared. How is ds dt related to dx dt, dy dt, dz dt? First of all, that formula is a little bit interesting. That's the length of a diagonal inside a rectangular box. I don't want to dwell on that too much. But you can kind of see it was basically the Pythagorean theorem, and then it's applied yet another time to get that diagonal of a box. Won't dwell on it, but just think about that for a second. You've got a box. Oops, that should be dotted also. You've got that diagonal running from this corner up here to that back corner. And it turns out it's just really a triple Pythagorean theorem here. A Pythagorean theorem almost in 3 dimensions is what we're thinking about there. Okay, so how is ds dt related to dx dt, dy dt, and dz dt? Well, let's take the derivative with respect to time. And maybe there's one thing you might want to do first, because I kind of notice here that square root. And if we think of a derivative, it's like, oh man, a half power. Bring that down, make it 1 less, the chain rule. And we can certainly do that. Or I guess I would suggest let's square both sides. So s squared equals x squared plus y squared plus z squared. Let's start with this. Let's now take the derivative. And we're taking the derivative with respect to time. Take the derivative of both sides. And again, I could have done it without getting rid of the square root. Well, we're going to get the same answer. I'll take the derivative with respect to time. Left side, s squared gives me 2s ds dt. The right side gives me 2x dx dt, and a 2y dy dt, and a 2z dz dt. Immediately, hopefully those 2's kind of stick out. Let's cross those out. And then I notice on the left side I have this s also, and I want to solve for ds dt, because how is ds dt related? So I'll divide by s. So ds dt is going to equal x dx dt plus y dy dt plus z dz dt, all divided by s. And maybe you don't want to leave s in your answer, so come back up here and say, oh, wait a minute, look right up here. Here's what s is in terms of x, y, and z. So we'll write it one more time, or I'll just erase that s. And s equals the square root of x squared plus y squared plus z squared. So that tells how ds dt is related to dx dt, dy dt, and dz dt. That completes the problem.